Now we're going to talk about negative exponents. This is the one more rule of exponents that we need to look at and learn about. So here's the deal. If a is a real number, and again a can't be 0, and n is some integer, then a to the negative n is equal to 1 over a to the n. Let's take a look at this. Let's say I have 5 to the third over 5 to the fifth. Well, the division or quotient rule for exponents would be that this would be 5 to the 3 take away 5, which would be 5 to the negative 2. But now let's do a little further investigation here. So this would be 5 times 5 times 5 over 5 times 5 times 5 times 5 times 5. So I can divide out these 5s and change them into 1s here, and it'll be a 1 on top, but still 2 5s on the bottom. So we can see that 5 to the negative 2 is equal to 1 over 5 squared. I look at it as kind of like a reciprocal rule, sort of, in that when it's a negative exponent, it wants to move to the other location in the fraction and become positive. So, keeping that in mind, we're going to do some examples using the negative exponents. Think of this as 3 to the negative fourth over 1. So, 3 to the negative fourth, the negative 4 wants to become positive, so it's going to be 3 to the fourth, and the 1 will go up on top using the definition. And then when I do this, I will get 1 over 81, because 3 to the fourth is 81. Now let's do the next one. 4 to the negative 1 plus 2 to the negative 1. Well, 4 to the negative 1, since it's a negative exponent, it wants to move to the other location in the fraction and become positive. And the same thing with 2 to the negative 1. So this will be 1/4 plus 1/2, which of course is 3/4, but if you don't believe me, we can make sure we have a common denominator. 1/2 is 2/4, so when we add them up, we get 3 over 4. Now let's do C. Well, if I think about it, 3 to the 0 is 1, and 2 to the negative 3 is 1 over 2 to the third. So this would be 1 plus 1/8, which is 1 and 1/8, which you can also write as 9/8 if you want to write it as an improper fraction, because 8 times 1 is 8 plus 1 is 9. And we can do this other one, which is x to the fourth over x to the ninth. Now I'm not moving anything because both of those exponents are positive. And when exponents are positive, they don't want to move. So I'm going to show you 2 ways to do this particular problem. The old-fashioned way, which says I have x to the fourth on top, which really means that, right? And x to the ninth on the bottom, which really means this. And I can divide out these x's. And I'm left with a 1 on the top and x to the fifth on the bottom. That's the old-fashioned way, which I personally like. It just makes a lot of sense. Or you can say, well, I'm going to use that quotient rule that says it's going to be x to the 4 take away 9, which will be x to the negative 5, and then that becomes, using positive exponents, 1 over x to the fifth. So y to the fourth over y to the fifth, the old-fashioned way, will become y times y times y times y over. I know, you probably think this lady is absolutely nuts, but if I visualize it, this will become 1 over y. It might be a little bit easier, or the other way you could do it is y to the 4 take away 5, which would be y to the negative 1, which would be 1 over y to the 1. So you can do it both ways. Whichever way can help you get it through the best is great. All right, so let's take a look at f. All right, so I'm going to think, now here's the deal. All of the exponents are positive, so nobody wants to move, and we're going to simplify as we go. Well, negative 5 over 10, negative 5 is not a negative exponent. It's just negative 5. So negative 5 over 10 is really negative 1/2. I'm going to simplify that just like a regular fraction. Now let's look at the x's. I have 8 x's on top, 3 on the bottom. So 3 of them are going to cancel out and get 1. So what you're going to do is you're going to think, well, how many x's are left and where are they? Well, there's 5 x's left and they're on the top. If you think about the quotient rule, 8 minus 3 is a positive 5, so that's going to be right on the top. But think of it, there's 8 x's on the top, 3 on the bottom. 3 will cancel. I'll be left with 5 on the top. Now let's look at for the y's. Y to the 11th over y to the 13th. Well, 11 of them are going to be canceling out, and I'm going to be left with 2 y's. But where will they be? On the bottom. Now, how about the z's? Well, they're both z squared, so they're going to cancel out to get the number 1. Z squared divided by z squared is 1. Again, none of these variables are taking on any values that are 0. They're never 0, so we don't have to worry about it. So this is, I made this big, huge, long fraction line for kind of nothing, but I always have to be a little dramatic. And then I'm going to rewrite this, clean it up a little bit, negative x to the 5th over 2y squared. Let's look at g. Again, we only move things that have negative exponents. So 4s squared is going to stay where it is. But s to the negative 5 will come down as s to the 5th. And then I think of it this way. I have 2 s's on the top, 5 on the bottom. 2 of them will go. We're left with 3 of them. Where will they be? On the bottom. The 4 stays where it is, on top. I'm not moving it at all. Erase that 3 and put a better 3 in there. All right, let's look at the last slide. Okay, so these are a little bit more complicated, but don't panic. First, on I, we're going to raise that to the 3rd power, everything. So it's 2 to the 3rd, x to the 12th, because raising a power to a power you multiply, y to the 9th. And then in the denominator, we still have to raise that also. So it would be x to the 21, y to the negative 3. So here we are, we're psyched. I would like to move that y to the negative 3. Again, it's the only one here that has any kind of negative exponent. And I want to make it positive first so that I can kind of look at what's going on. So let's clean it up a bit. 2 to the 3rd is 8. X to the 12th, y to the 9th. Those don't move because they're positive. X to the 21st does not move because he's a positive exponent. But y to the negative 3rd is going to move. Where? To the top as y to the 3rd. So cool, right? Now I get the 8. Now I have x to the 12th over x to the 21st. So 12 of them are going to cancel, right? So how many are left over and where are they? Well, there's going to be 9 left over and they'll be on the bottom, right? Because 21 take away 12 is 9. So I know that there's more x's on the bottom, so that's where they're going to be. And then I look here at my y's, they're all on the top. So I get y, 12 of them on the top, and I'm done. Okay, there are many ways to do this, but I really feel that moving things around and making them positive exponents first is better. All right, let's take a look at the next one. We are going to make it so we're going to raise the power to a power, so it'll be 3 to the negative 3, x to the regular 6, because negative 2 times negative 3 is a positive 6, and in the denominator will be y to the negative 15. Now we're going to rearrange things. The only thing that will stay put and not move around will be x to the 6 because it's positive. 3 to the negative 3 will move downstairs as 3 to the 3rd. And y to the negative 15th will move upstairs as y to the 15th. So this answer becomes x to the 6th, y to the 15th, and the denominator will be 27 because 3 times 3 times 3 is 27. Now you could leave it like this in the numerator, but you know, math types are alphabetical order fiends as well, so there you have it. So now you're ready to go on to do more like this in the book and then in my math lab. You can do it, just keep at it, keep asking lots of questions, and don't give up.